Hello, I'm Brendan Ranham, and I am reviewing the academic papers by Hu and Wang regarding the Kubernetes autoscaler based on pod replicas prediction. Kubernetes ships out of the box with its own horizontal pod autoscaler, which is very simple. It just compares the running numbers against set thresholds and then just the numbers running up and down. This has a direct impact on application quality of service measured in response time. Why is this still a problem? Kubernetes is still the de facto standard. It uses its pods, which are shared network storage and containers, has its simple HPA, and instead of offering alternative strategies internally, they've published an API so you can go and roll your own. Other people in this area have offered up a fractal load strategy there, flexible expansion component based on moving average, and a load forecasting based on double exponential smoothing model. That last one's quite interesting because it feeds into our main idea, which is an automatic HPA scaling strategy. Surprise. This one collects the resource usage history and then via a triple exponential smoothing model predicts the number of pod replicas. Then it will scale those pod replicas in advance, and this is meant to reduce the application response time. So down on the bottom left there we have an interesting diagram which basically shows the engine here feeding into that bottom right box, the API server, which controls Kubernetes stack. And then briefly described there are the algorithms for invoking pod scaling up and pod scaling down. Fairly simple. The tricky bit is the triple exponential smoothing model, which has a fair bit of mathematics behind it, and I invite you to read the paper. Now, does it work? So what we're looking at here is number of requests coming in on the left. That's over 1 day. So they've basically used one type of load, which is a repeating pattern across a day, say a factory during weekdays, for example, or possibly a shopping website. On day one, the authors note in the paper that they didn't actually have the history loaded. This kicked in on day two, and you can see on day two, the slightly more orange and upper line is actually the predictive HPA, slightly leading and actually invoking a couple more pods than the normal HPA that comes with Kubernetes. Same thing on day three. And the response time there at the bottom graph is actually quite dramatic. So the orange is the original HPA that comes with Kubernetes, and then down at around roughly a fifth of the response time is the predictive HPA. So using this model will increase responsiveness in your web application and reduce the response time down to about 20%. Pretty fantastic result. What they did to check this was they ran up 4 Linux servers in a standard Kubernetes cluster, one with the master and 3 workers. Machines all had the same configuration, quite standard kit, and then ran it against the load patterns. So critiquing, these were 3 compact pages, very quick to get through, extremely easy to read. I found it had an excellent layout and style, a very clear description of the problem and their cure for it, and the mathematics behind it. The testing method was very clear, and the results are very clear with supporting graphs. Really great result. However, they didn't actually compare themselves against others who've done some work, and I would have really liked to see what the difference between a triple exponential and a double exponential smoothing algorithm would have been. Overall, a recommended read. That's it from me. Ciao, ciao.